Hello, my name is Noreen Dobiesz. I've been using computer models to help inform Great Lakes fisheries managers for almost 15 years. This research project I'll discuss focused on the impact of the sea lamprey control program on lake sturgeon restoration. Lake sturgeon is a charismatic fish species listed as imperiled in both U.S. and Canada. It's culturally important to the Great Lakes tribal communities and has been the focus of considerable restoration efforts. For all these reasons, the loss of any lake sturgeon is a serious concern. Sea lampreys are an invasive parasitic species that prey on large bodied fish in the Great Lakes, frequently killing them. To control the number of adult sea lamprey, the Great Lakes Fisheries Commission treats streams and rivers with a lampricide that kills a proportion of larval sea lamprey, thus limiting the number of adult sea lamprey. Lake sturgeon survival is influenced by sea lampreys directly through parasitism on adults and through lampricide toxicity on age 0 sturgeon under 100 millimeters in length that inhabit the streams during lampricide treatments. If sea lamprey treatments are delayed to minimize the negative impact of age 0 lake sturgeon, more adult sea lampreys may be produced, thereby increasing parasitism on adult lake sturgeon and other important fish in the Great Lakes, such as lake trout. As a result, the maximum attainable size of a lake sturgeon population and their abundance is a trade-off between mortality impacts on two different age groups of sturgeon, age 0 and adults. Managers needed better information to examine this trade-off. There's no easy way to test the trade-off in the field without further contributing to losses of lake sturgeon. So we created an age-structured lake sturgeon population model that uses information about lake sturgeon reproduction and mortality, and then simulates a growing population over 100 years or until the population reaches an equilibrium. We ran the model using each trade-off scenario to see which resulted in a higher equilibrium population size. Our results showed that reducing sea lamprey predation on adult lake sturgeon results in a higher equilibrium population size than reducing mortality on age 0 sturgeon. Thus, management efforts to reduce the number of parasitic sea lamprey are more likely to aid the recovery of lake sturgeon populations than reducing the use of lampricide to limit toxicity on age 0.